In example 1, we're given the cosine of 75 degrees and asked to find the exact value. With your previous knowledge, you won't be able to do this. This is not something that appears on the unit circle as one of those special right triangles. However, we do have some formulas that we can work with. So at this time, if you haven't filled this out in your Trigonometric Identities Toolkit yet, please do, and we're looking at this area right here. The sine of an angle plus or minus another angle is equal to the sine of the angle, cosine of the second angle, plus or minus the cosine of the angle times the sine of the other angle. You could use x and y here if you prefer. These are just placeholders for two different angle measures. Notice how the plus sign is on the top here, and also the plus sign is on the top here. So if you have an angle plus another angle, you'll use a plus sign in the expanded version. And if you're using a minus sign here, so you have one angle minus another angle, you'll utilize that minus sign here. If you take a look at the other two, and especially this cosine one to begin with, you'll notice that if you have an angle addition here, so if you're adding or using the sum of two angles, you need to use a minus sign in your formula. So if you're using the top one, then you need to use the top one here. The top operator is what I mean to say. Down here in the tangent, you've got kind of a combo. So here, if you're using an addition sign, you'll need to use an addition sign here, but then a minus sign in the bottom. If you were doing a difference of two angles, or using the subtraction symbol, then you would do the tangent of alpha minus the tangent of beta here, but then use the plus sign. So whichever one you're using on the left, top or bottom, then that'll tell you which one to use here on the right-hand side. Pause the video if you need to write these down. We're going to continue on then, and we're going to utilize one of these formulas to try to help us figure out the cosine of 75 degrees. Now, the cosine of 75 degrees, as we said before, is not on the unit circle. And what we want to do is we want to try to write this as the sum of two angles that are on the unit circle or that are part of a special right triangle, 30, 60, 90, 45. So I think right now we could do 30 plus 45. Just try a few different combinations if it doesn't jump out at you right away. And the more you do of these, of course, the easier it's going to get. And so we note that 75 is the same as 30 and 45. There's a common student error here, and that is to try to do the distributive property with this cosine. The cosine you can kind of think of as an operator. It's not three letters on their own, like variables. It's not something that we could distribute here. It just doesn't work like that. You don't get the same result. What we can do, though, is we can expand this using our formula. And here alpha is going to be 30 degrees and beta is going to be 45, and remember we're adding. So if we take a look at all those formulas, we have one here that'll help us. It's the cosine, so we're going to look at this one. And we're using a plus sign, so we'll use a minus sign here. So this is going to be equal to the cosine of the first angle, which is 30, and then the cosine of the second angle, which is 45. Oops, remember this is a minus sign. And then sine of both of those angles. So it'll be sine of 30 and sine of 45. The cosine of 30 degrees is root 3 over 2. The cosine of 45 degrees is root 2 over 2. And I'll indicate multiplication here by using parentheses. You can also put a little multiplication dot there. That's fine too. We'll have the minus sign. The sine of 30 happens to be 1/2, and the sine of 45 is root 2 over 2. If you're having trouble coming up with those values, check your unit circle, or you can also draw yourself a nice reference triangle. Note that these are all in the first quadrant here, so they all should be positive, with the exception of this sign. Remember, for the formula, the sign needs to be the opposite, and that's with cosine. What we can do now is a little bit of order of operations here. So we can do root 3 times root 2, which is root 6. 2 times 2 is 4. 1 times root 2 is root 2, and 2 times 2 is 4. Oftentimes it's a good idea to state this as one fraction. So we will write this as over 4. And it turns out that you can't do this root 6 minus root 2. Remember, that's a rule from algebra. You can do that if it's multiplication. You could make that root 12 if you wanted. However, when there's a subtraction symbol, we need to have the same number underneath the radical sign. And anything underneath the radical sign is called the radicand. And remember also when we're combining fractions that we just take the numerators and do the operation that's indicated and then write our denominator down once. You can verify this fairly easily by just plugging it into your calculator. Make sure that you're in degree mode if you're using degrees, so I actually have to move my calculator into that area, and we're going to do the cosine of 75 and hit enter, and that's the decimal approximation. I'm going to group together root 6 minus root 2 in the top. If your calculator doesn't have that fancy horizontal fraction bar, you need to tell it to group those, because the calculator does this little backslash, and the little backslash does not indicate grouping. You got to group it on your calculator. We're going to divide that by 4 and see if we get the same thing. Voila, check it out. We do get the same value. So using the formula, we can get this exact value, root 6 minus root 2 all over 4. Your calculator is good at approximations, and it's good at checking work like we did here as well.